Okay, great. Well, hello everyone. Welcome to our sort of workshop on discussion, which we're going to be presenting you our work in progress on exploring the participatory systems map of the transport system, which has been focused around the trilemma or trade-offs between COVID, carbon emissions, and air quality. And I'll talk a bit more about that in a sec, but I'll just let Suzanne say hello and introduce the projects that we're part of briefly, so you know who we are. Suzanne?
Hello and welcome everyone. It's fantastic to be here and to see so many of you. So thank you very much for joining our workshop session, which we hope will be very interesting, certainly informative for ourselves. So my name's Dr. Suzanne Bartington, and I am a researcher investigating air quality impacts upon health at the University of Birmingham, and also linking through to public health policy and broader public policy. My role here is as network lead for the Transition Clean Air Network, which is one of 6 UK-wide networks funded under the Strategic Priorities Fund programme. This is really intended to bring together organisations working on air quality across academia, the public, private sector, and not-for-profit sector to coordinate our work. And we're focusing on optimising the air quality and health benefits associated with transport decarbonisation, which is the core focus of this session here today. But we've joined up with the ANTICIPATE study, which also was funded by UKRI under the umbrella of the Clean Air SPF programme. And ANTICIPATE is led by Professor Nigel Gilbert at the University of Surrey, who isn't with us today, but leads the study as a programme as a whole. And the focus is on the unintended consequence of public policy for air quality. So thinking about those elements outside the core areas of air quality policy, and how do they impact upon air quality in both positive and negative terms. So we've come here today with a focus on transport decarbonisation specifically, and we're really hoping that you will find this interesting, informative, and enjoy the session as well. So thank you.
Great, thanks, Suzanne. So yeah, I'm Alex Penn, and I am currently working on the ANTICIPATE project. And what I have brought to this project is my my sort of research area, which is on participatory systems mapping, or taking complex systems or whole systems approaches to interconnected challenges. So we think this is worth doing in this space because obviously we're interested in air quality in general, but the work that we're going to show you today, as Suzanne says, focuses on the transport system. And the transport system is a complex system, and that means it has many interacting elements and different domains and interconnections between them. It's a very big interconnected system, not just in the sense of a technical physical system. Of course, there's interconnected infrastructure and technical elements, but it also interacts with many other factors from different domains, and what actually plays out in this system in use, in practice, and how it works and how people use it is the interaction between all sorts of things: geography and environment, people's behavior, planning, policy, economics, societal dynamics. So to actually understand the transport system in use and how any policy that attempts to intervene in that system might actually play out, or how changes might play out in that system, we really need to get a whole systems picture of all of those factors from different domains and their interconnections. You know, because we've got this system that really has to deliver a lot of outcomes simultaneously. It's another kind of classic problem of a complex system. We don't just want to reduce carbon emissions, we also simultaneously want to improve air quality. We want equitable access to services and livable places. And again, if we want to achieve all of these things together and achieve synergies between these things, we really need to understand the whole system. But because of these interconnections we have, and the fact that people have different values and want different things, when we intervene in these systems, we have the possibility of quite unexpected indirect effects happening. So, I mean, you're probably all aware that policy that promoted diesel vehicles and thinking about trying to reduce CO2 emissions has inadvertently led to problems with air quality. So what Anticipate is really looking at is how can we avoid these unanticipated indirect effects. But, you know, thinking about the whole systems approach isn't just about avoiding negative consequences. If we understand the system, we can also potentially find where there might be effective places to interact in the whole system to create policy synergies, to mitigate the negative effects of policy. Or we might find that there are high leverage points in the system, factors that we have influence over that can have very large effects. So there's lots of reasons why we want to take a whole systems view, but not just a whole systems view, but a view that brings multiple people's, multiple stakeholders' knowledge and values and perspectives together. And the methods that we've been using to try to do that in this domain is participatory systems mapping. So essentially, a participatory systems mapping is it's a sort of workshop technique in which we bring together a group of participants to collaboratively construct a causal model of their system. That means what are the factors or components in the system and what are their interconnections. So we look at the interdependencies within a system. So you can see in the photo here, before COVID, we used to do it this way in a workshop setting with people all gathered together, diverse people who have different sorts of knowledge about a system, with post-it notes and pens, and we collaboratively come up with an overview of the whole system. These people here that you see are looking at the bio-based economy in the Humber region, and there's people there from industry, from local authorities, from economic regeneration, from community organizations. Together, they're building a model of that system. They build it together, so they have the opportunity to discuss things and raise and make explicit their different perspectives. So this kind of method, it can capture really diverse knowledge and perspectives on a system. Really crucially, we can include things in a systems map that are qualitative as well as quantitative, and that will become a bit clearer on the next slide. So we can capture anything that matters. We don't have to have empirical evidence. We don't have to have a kind of numerical value for it. So, and then once we've built a map, we can actually do bespoke analysis on it. And our aim is always to get usable insights from the maps we do. So a map looks something like this. This is a very lovely, simple map. And the one that we'll show you in a few minutes, unfortunately, doesn't look as beautifully simple as this. But this is the map that the people in the workshop that I just showed you in the photo before produced of bio-based energy production in the Humber. So you can see here we have one sort of focal factor of bio-based energy. And immediately what you can see, we've only got about 20 factors here, but we've got a whole array of factors from different domains. So we've got very quantitative factors such as fossil fuel price. We've also got things that people felt were important in what actually plays out in the region, but that really can't be quantified. So say community acceptance of new industrial development. And we have these factors, the factors that people generated, and the causal connections between them. So what these arrows represent is not just a correlation, but a cause. We have a kind of understanding or an idea of what a mechanism is for any of these arrows. They all represent a causal mechanism. So here, for example, you have number of jobs generated by the bio-based economy. If the number of jobs is going up, the factors go up or down, they're variables. That's the sort of sole constraint we have here, really. If the jobs go up, then we have a positive connection here, which means this changes in the same direction. So if the jobs increase, the community acceptance of new industrial development increases. So we've got a sort of strong link here between jobs and community acceptance of new development. We also have negative factors, which mean essentially that that if one factor goes up, the factor that it's connected to goes down. So if infrastructure, new built infrastructure is increasing, then there's an impact here. People are less accepting of new development. So the more infrastructure increases, the less accepting people are of development. So we have this quite sort of simple sort of map structure. And you can transform these into numerical models, but that's actually quite problematic if you're using a mixture of factors which you don't have data. So what we actually tend to do instead is to look at these with network analysis. And we're not going to go into any technical detail. You're really welcome to talk to us about this. We'll show you a little bit about how that works. But essentially what we do is two sorts of analysis. We look at which factors are the most influential in the system by essentially looking at how many connections they've got or what position they've got in the system with sort of network analysis measures. And some of these are quite simple. So, and they really all correspond to sort of questions we might ask. So one network analysis measure would be the out degree. And essentially that's just how many outgoing connections any given factor has. So we can calculate that across our systems map. And having a high number of outgoing connections means you're quite likely to be an influential factor. You influence a lot of things. Change in that factor will influence a lot of things. So we can look at which factors are the most influential. Similarly, which factors have a lot of things coming into them. They'd have a high number of incoming connections. That essentially allows us to ask, what are, the different drivers of a factor? So what's influencing a factor? So we can look at the different factors we've got. What do they influence? What influences them? And we're very often asking specific questions about factors. So we can do this sort of general analysis, but really quite often we've got specific questions that we want to ask. So say an example in a systems map, we've got a policy intervention, a factor that we think is going to change with a policy intervention, or it might change due to an external risk. So what we want to pull out of that systems map is, if that factor changes, what are all the causal impacts? What are all the pathways of cause coming out of that factor? So what might it change, and what might be the possible indirect effects of that change? So we would pull out a submap, essentially starting from a factor that we think may change, from a policy, from an intervention, something that we're thinking about that might change, might be changed by us, be changed by external circumstances. And then we can start to look at everything that might cause and start to ask questions there. And we'll do that in the exercise in a minute on the map we've got here. We also then might want to sort of ask, well, what influences a particular factor? And that might be particularly important if there's an outcome we really care about in the system. So it might be carbon dioxide emissions, it might be mobility equity. What are all the things that feed into that? So we pull out of our big map all of the causal paths sort of feeding into that factor. And again, we may see things that put the outcome we care about at risk. We will see things coming into that factor. Even if we've got a policy trying to influence that factor, there may be other external things also influencing that factor. So we can start to think about what's influencing this. Are the risks there? Are the synergies we could exploit? And then really, if we want to kind of just look generally at how a factor is connected within the system, we can look at all of the connections that it's got. And that's essentially all of the ingoing and outgoing connections, which is called the ego network. And we can start to see around groups of factors whether there might be trade-offs between them, whether sort of the increase in one might lead to a decrease in another. So do we have trade-offs between carbon dioxide emissions and air quality, for example, that we weren't aware of? Or are there potential synergies between things in the map? So we really start to use these maps as thinking tools, and normally really very much combining with information on factors in the map. So who's controlling what's important to who, what can we influence? We very much kind of design the analysis to fit the questions. So hopefully, next slide. So, we're using this kind of analysis to really to come up with systems informed questions that are meaningful in a particular context. What are the potential unexpected indirect effects of policy interventions or changes? What are the influences on key outcomes? What might be a risk to policy outcomes or outcomes we care about? Where might there be opportunities in the system if we have influential factors that influence things that matter? Are they things we can use as levers? What trade-offs may exist in the system? And once we've done this kind of analysis, we can start to go further and start to ask some questions. If we see that there are unintended negative effects or trade-offs in the system from change, what can we do to mitigate those using our sort of systems informed perspective? Can we capitalize on or create potential synergies or reinforce synergies that we see in the map? Can we make them stronger? Can we design interventions that leverage the system structure, factors that are more influential than others? Can we actually design interventions that take advantage of that system structure? Okay. So I can see I'm kind of going on far too long. We'll go into the map proper and have a look at it. But just to say, this is what that looks like in practice. So here I talked about before downstream analysis. What do factors cause? We've pulled out a submap from a larger map here, which had something like 100 factors, and we were interested in different scenarios. This is a map done in the Medway River catchment, looking at water systems governance, and we looked at economic futures for this map. So things that might change. Food production versus designing for transport infrastructure, the Medway as a gateway for Europe. We pull out everything that comes out of those changes, everything that's causally related to them downstream, and all of these pink factors. I don't know, you probably can't actually see text on them, but we can start to look at everything that might be influenced by increasing food production and how it's influenced. So all of these things here: local economy, quality of natural environment, soil health, business resilience to extreme weather, sense of place. These are all things that are influenced by that. And we can look at these connections and say, how might these things be influenced? Are there unexpected impacts? How does this work? Equally with transport infrastructure, what does that influence? Local economy, heritage assets, flood impacts. We see lots of negative potential impacts here around flood impacts and flood risk, coming from the focus on the transport infrastructure, and potentially negative impacts on soil health. So how do we mitigate those? So you can see we're pulling out something that's coming out of a factor. This should get a bit more real when we look at the real map, I hope. Equally looking at inputs into a policy. This is a map on the carbon, the energy trilemma that we did with Bayes, just a sort of pulling out of a policy outcome here, tons of carbon emitted. So we looked at what was directly feeding into that policy. This is looking at upstream analysis that I mentioned, and we can start to see everything that influences the policy outcome. So one policy, but all of these additional other things are influencing that policy. So that shows us how we need to think to mitigate against potential risk to our policy. Right, I'll skip over this, but I briefly, this is a very influential factor in a map that we did with DEFRA. So pulling out a fact which is about farmer behavior, which influences an awful lot of important things here in the system. Orange and red factors shows us where we've got a potential system lever, and we do work to think further how we can use that. But I'll just skip over that, and we'll go on to the real thing and make it a bit more understandable. Just to say that what we're showing you today is a sort of experimental response that we had to kind of come up with really in response to the pandemic. So we've done a lot of this sort of systems mapping work previously with all sorts of different government departments and with local communities and different stakeholders. And previously it very much looked like this. You know, everyone's together around a table, really kind of having a great discussion together and building a map and kind of unearthing their collective understanding of a system and sort of getting those aha moments by talking together. We then put it into some software, you know, so we bring everything together, and this is in Gephi, a network analysis software. This is a map we did with DEFRA on the future farming and countryside policy area, huge policy area. So we put it into sort of software and then and do analysis, the sorts of analysis I showed you using that software. Fortunately, as COVID hit and we were about to start all our workshops, which we obviously couldn't do anymore, we had an experimental piece of software that Nigel, the PI of the group, was sort of building in his spare time, which is called Prism, which is an online systems mapping building tool, essentially, which we would encourage all of you to play around with and have a go with. It's free to use and access. So here, the idea is that people can collectively get together and online build these systems maps. And then we are starting to kind of get into designing the analysis tools that we would normally have into this online software also, so that people collectively can build a map, but also start to analyze it themselves. But this is quite experimental. It's very much work in progress, and it's what we're going to be looking at today. And there's a lot of learning involved in moving from a kind of in-person context really to this online context, and the interactions that happen can be quite different. So you're going to get a chance to be looking at this experimental software today. Very exciting. And the map we're going to be looking at today is essentially it's a map that we've done with the transition network, the transition team, and the Anticipate team, focusing on the COVID-19 carbon emissions and air quality trilemma. So the idea behind this exercise was that essentially COVID is exerting major impacts on citizens' personal transport patterns, and there may be actually longer term risks for transport decarbonisation policy in the UK that they may come out of this. And we're already seeing changes in transport choices, provisions and investment. There might be kind of longer term impacts of some of the short term responses to COVID, and this may put the transport decarbonisation plan at risk. Additionally to that we often see a trade-off between carbon emissions and air quality and policy, and we wanted to sort of capture the interaction between those potential trade-offs and COVID impacts. So to take a whole systems approach, build a map of this system to try to kind of look at designing interventions which improve all the outcomes that we want, promote synergies, and sort of buffer against or work with the system's vulnerabilities and maybe the impacts of COVID that are coming up. But really the aim ultimately is for us to generate actionable insights for policymakers regarding transport policy. So we created a map of the personal surface transport system around this COVID carbon air quality trilemma. So it's a system in use. We started from key outcomes, carbon emissions, NO2 emissions, PM emissions, but also social factors, mobility equity, connectivity, neighbourhood self-sufficiency. So our starting point for the map was already quite broad. We brought together stakeholders from the Transition Clean Air Network, from transport providers, local authorities, NGOs, academics, all with an interest in this area, to think about the factors that they felt that were from any domain that impacted on or were impacted by these outcomes and their causal interconnections, generate those factors and start to build a big map together. So this map was created first in 2 sort of joint online workshops, much shorter than we'd normally do in a whole day, 2 3-hour workshops, and then a lot of one-to-one sessions with people adding stuff in. So it's a sort of work in progress map, and I'm going to show you the map. If I can get to the, I'll stop the share and then start it again and show you the sort of what the map actually looks like that we've built. And then we'll come on to what we're going to do with the analysis. So prepare to be maybe slightly horrified. So this is the map as it stands. It's just an overview at first. I wouldn't expect you to be able to read. Can you see the map? Are you seeing the map?
Yep, yeah. Yep.
So you can see already that we've got an enormous map, a really enormous map, just from these few sessions. And I'll just to give you like a little kind of brief tour of the sorts of things we've got here. So we've got a huge number of things in this map. So the orange factors that you see are sort of key outcomes. So things like the different emissions types that you can see down here, emissions. Can you see that, the text? When I zoomed in enough for you to see the text there? So we've got all of the different sorts of emissions that we're interested in. So the system is getting a bit non-responsive here. And then over on this side of the map, we've got different sorts of modes and how those are feeding into the emissions. So we've got a whole section over here on, say, electric cars, charging infrastructure, which is what we're going to be exploring in a moment. We've got private cars, fossil fuel cars up here. We've got all these different modes, public transport factors here in the center. We had a lot of input from the first group, so we've got a lot of stuff on buses and all of the factors that influence that. Up here we've got things around congestion, driving, parking restrictions, and how that impacts and connects to the rest of the map. And we've started to really we've got a kind of area that's really about demand for travel, so focused around different journey types, number of short journeys, number of long journeys. We've got all of these factors such as choice of school, movement, travel for holidays, what people are doing with their time, everything that drives demand for transport is sort of up in this area of the map. We've got a whole other sort of section up here on planning policy and factors around planning and geographical planning in urban areas. So housing density, different sorts of development, and even moving into things like social norms of distance traveled, commuting distance. So you can see already that the map is pretty broad. You know, so we've got all of these things that are sort of actually looking at the spatial planning, the sort of geographical aspects of the neighborhoods in which people are living, the economic aspects, the job catchments, the number of jobs of different types. And then we've started to kind of develop an aspect of the map on home working, which we're expecting to be quite impactful. We've got a lot of factors really over here on socio-demographic mobility, equity, and a lot of stuff here on neighborhoods, walkability of neighborhoods, community severance, time outdoors, which all start to feed into physical activity, to health, and to exposure. So we've really sort of got our health factors over this side of the map. It's quite, we certainly send you a link to this afterwards, and you're very welcome to kind of explore and go through, but just for now, I think you can see there's a huge kind of array of different things in the map. It's very much a work in progress, but you can see the sort of range of stuff that is covered. We're going to explore it. I'm going to kind of leave it to Suzanne to discuss what we're going to explore. Do any of you guys, Suzanne, James, want to say anything about what's in the map?
I'm just going to chip in there because we had a couple of really interesting questions in the chat, one of which I have addressed, but from Louise here about whether participants have added their own factors to the map or facilitators have done so. And I've just replied to say it's been a learning process for us with the online workshops with participatory mapping as a process. And also a question about the colours of the link. So it's just to explain that green is positive, red is negative, and black is complex with regard to the links on the map in front of you as well. But Alex, I don't know if you briefly just want to say anything more about the undertaking participatory systems mapping online versus in person.
Yeah. So that I mean, we actually have as Suzanne said, it's very much a learning process. So essentially, in a face-to-face mapping workshop, for the most part, you try and have everyone in the same group, although that's not always possible. And together, we normally start with outcomes that the participants themselves would say these are the important outcomes for the system. Here we generated some important outcomes and asked people to add more if they wanted. And then everyone would brainstorm what they felt were factors from any domain, but really, you know, from their knowledge, which influenced those outcomes or were influenced by them. And we'd have a process where we get all of these up on the wall as post-it notes, and then as a group really spend a lot of time discussing and clarifying that and coming up with all the factors we could agree on that we wanted to have in the map. So that's very much a group process. So here we had this kind of just immediately with doing this online, we had to sort of split into smaller groups really to be able to do it, to be able to have the same level of interactivity with people. So we wanted to sort of have a scenario in which we'd all agreed on factors, and then we could split into our groups with the sets of factors that we could agree on, build maps, and then consolidate the maps together again. So we did have this process of all brainstorming factors together, and then splitting into groups, but inevitably then the sort of the definitions of what the factors were, I think, started to diverge a bit in the groups, and people were adding in more factors. So we had a sort of explosion of factors really, which is quite interesting, that we've been working to sort of try to rationalize a bit. And I think, you know, one of the kind of key interesting issues really was when we do this in person, we'd normally have sort of several, one or, you know, two at least full day workshops, but really it's people don't have the energy to do that on Zoom essentially. So it was very much a feeling that we had to sort of do it in 2-3 hour sessions. So I think because we didn't, you know, quite often in a workshop we take half a day, we take that 3 hours to just decide the set of factors we were all agreed on. So I think because we've done that in a kind of more rapid way, we've ended up with a bit of an explosion of factors. So again, that's for us to sort of come back to in next time. But I mean, yeah, I mean, it's crucial that participants are able to generate what they think is important and agree that amongst themselves. But I mean, I think it is a learning process of how we can effectively do that without this giant explosion of maybe unnecessary factors in a kind of online workshop context. I don't know if that hopefully that answers. It's probably far more detail than anyone ever wanted to hear, but it's very interesting. I mean, it really is different doing it online, actually. You know, there's a lot of things that make it different, and they're very much often about group dynamics, and so it's a very interesting learning process for us.
And we're learning more today as well in the workshop. So
yes.
Thanks, Alex. I think that hopefully addresses Louise's question. So shall we move on to consider the policy? Because I think those of you who are new to the systems mapping, it will make more sense when we go to a distilled version of the map, appreciating it can be somewhat overwhelming.
Yes, everyone is overwhelmed when they see it for the first time. So let me go back to the PowerPoint. So, Suzanne, do you want to?
Yeah, so really just to set the context of what we're going to go on to do now with your input is really to identify a policy, and really the intention, as I said at the outset, of Anticipate is to really understand and be able to modify policies at formulation stage ultimately, but to really be able to understand the unanticipated consequences of these public policies, and which we know have ripple effects far beyond the intended outcome of interest in their own right. So we've selected to focus on today the sort of flagship announcement within the Green Industrial Revolution, which was released at the latter part of last year, preceded the Transport Decarbonisation Plan, which was released in July. But really to focus on this announcement around investment in electric charging infrastructure, particularly with a focus on targeted rapid charging points along the arterial road network and motorways, and also on-street charging for homes and workplaces as well. So the sort of context for this, of course, is 2030 as being the date for end of sale for petrol and diesel vehicles, and a requirement for all vehicles to be 100% zero emission. That's tailpipe emissions. We could have a whole discussion about that by 2035 as well. And if we actually look at this specific policy or strategy, really, and again, we've done some work in Anticipate discussing what is a strategy and what is a policy, but if we refer to it here broadly as a strategy, because there'll be a number of policies coming out of it, but the milestone is really to deliver over 2,500 high-powered charging points around the UK, and also underpinning that is a levelling up agenda with a particular focus on Midlands and the North East as well. Obviously, that links through to other industries such as manufacturing. It is market led as well as a policy in terms of who is actually going to be responsible for delivery. And obviously, it has major implications, both for the sort of technical challenges, the actual hard infrastructure, as well as the social fabric of the UK. And if we move on, think about travel behaviours as well. So this is the sort of context, the policy which we want you to think about. And I'm going to hand back to Alex now to take us back to the map itself that we're going to be looking at.
Yes, and just to say before we start, I mean, essentially what we're going to really focus in on here is the promotion of electric vehicles and charging infrastructure. And ultimately what we hope to do here is this sort of stress testing to identify consequences for clean air and climate change, and potentially other social unexpected outcomes, social or other. So what we're going to do is just start doing a downstream analysis from the factors that are directly changed by the policy, and then start to think, what do we see? What questions do these raise? What's going on? What's missing? So, and ultimately, so as I say, the map is a work in progress. So we'd really appreciate your input on sort of, firstly, examining what you see coming out. Does this make sense? Are there things that are missing? Ultimately, how could we mitigate things that we see coming up or design better? But we'd like to just have this as quite a free discussion. We'll start with this, and we'll start to sort of show you what kinds of things we can do with this analysis. But please feel free, we'll bring you in, but just to suggest, what would you like to see us have a look at in the map based on what we're doing? And then I think we'll start to have a discussion, hopefully, about not just what we're seeing in the map, and how you might like to explore it, which, please just throw in comments, unmute yourselves and suggest something, or raise your hand maybe, so that Kirsty can alert us. But then we'll have a look at this and we'll start to think about overall, I think, systems thinking in transport. So, right, I'm going to stop again the share and switch over to the map. I can escape my PowerPoint. Oh, sorry about this. I'm trying to share again the map. Okay, can you all see the map? Yep. So I'm going to take you over here and tell me if this is zoomed in enough for you to read. Is it zoomed in enough? Give me a thumbs up.
I think we might need to go in a little more, Alex, certainly.
How's this?
For my screen.
Does that work for people? Can you see? Can you see the factors?
Got some thumbs up. There is a yes and no reaction, isn't there, now on Zoom? But yeah, I'm seeing some thumbs up. So
okay, great. So, starting from the factors that we think, should be directly affected by this plan, we want to look at what might be the impacts. So the factors we're starting from here are, so I'm going to select them: charging infrastructure, proportion of electric cars. We've got in number of electric cars, and we also put in total distance traveled. So I've selected all of these factors, and you can see here, I'm sure Nigel will be extremely pleased if you went and made your own maps and played around with them after this. I can analyze the map. I can start to do some of this sort of network analysis I talked about. So here, I'm just selecting from those factors that I picked: charging infrastructure, proportion of electric cars, number of electric cars, and distance traveled. Just the factors that are, all of the factors that are one link away. And I think what we'll start with is looking at what's downstream. So that is what is causally downstream of those factors, if that makes sense, by one link. So I've selected the downstream. I think Greg has raised a hand. Greg, would you like to say something?
Yeah, thanks, Alex. I'm just wondering, the charging infrastructure, there is a debate about the extent to which charging infrastructure leads or lags the proportion of electric cars. So does it matter that the arrow is one way or the other?
Good question.
Or should it be complex?
So at the moment, we've got a black link here, which means we've got a sort of complex connection between charging infrastructure driving proportion of electric cars. But I mean, actually, it's a good point. We haven't got a feedback from, say, number or proportion of cars to charging infrastructure. So that actually might be something that we might need to include. This is the kind of thing we always have to sort of, well, I think once we start looking at it in any detail, we're always finding things that we might want to include. So I'm just going to move through this briefly, just to sort of, can you see the text if I'm zoomed out like that? You can see here. I think you probably can't. So what I will do is I'll just kind of give you an overview of what the downstream analysis looks like, and then we might zoom in on different parts of it. So this is the factors that are one step away from any of these factors that I selected. And and please, Suzanne or James, feel free to sort of chime in here. I mean, we can obviously see that we've got some things that we might hope for or expect here. So we've got the number of electric cars decreasing CO2 emissions, but we've also got them increasing vehicle weight and hence increasing non-exhaust emissions. And we've also got already, we're just within this sort of small submap of one step away from those factors, we've got impacts, complex impacts potentially on active travel, distance traveled, and public transport distance traveled. So we can start to see that already there are potentially some things we might need to be alert to. I mean, here, in fact, what our stakeholders put in here was that the EV total distance traveled would actually decrease public transport distance traveled. And crucially, we know there's very good evidence for this, in fact, that Suzanne might want to go into, that we've got number of electric cars increasing, private car number of trips. If we start to sort of go out a bit further, what's someone else doing something on the map there? This is why I say it's work in progress with our new software here. We've let me kind of go back again. Okay, so there is a bit of a tendency for sort of unexpected things, unexpected consequences of the software to.
Whilst Alex is doing that, I'll just pick out a couple of points. So something which came up in the stakeholder discussion was this issue about potential rebound. So if usage of electric vehicles became essentially or cheaper at point of use of the vehicles, then you could end up with additional miles traveled overall. So your actual activity benefits are negated or become negative. And also another issue which we've been discussing is the sort of budgetary opportunity cost of investment. So if you're having this investment into charging infrastructure, which is being led by BEIS, then does that essentially pull away from other major infrastructure investment relevant to transport? So that's just a couple of points really to think about, but please do chip in with your thoughts. So this is a very dynamic process, as you can see, and we're very keen to add to the map. I think, James, you wanted to speak.
Thanks very much, Suzanne. So to the rest of you, Suzanne kindly introduced me in the chat. I'm Innovation Network Manager for the Transition Clean Air Network. I'm a Senior Research Fellow at the University of Birmingham with actual sort of dual interests in atmospheric science, i.e. in this case, air quality, and the built environment and design of the built environment. And I just wanted to take the chance to pick up on Eric Thomason's comment in the chat. I'd be very interested to talk with you further about the potential to translate some of these causal relationships in the systems mapping into a digital twins platform. I think Alex has alluded to some of the challenges in putting numbers to these arrows and, perhaps some caution in doing so. But it could be very interesting to explore as we start to put numbers to these arrows, quantitative relationships between factors. Could at very least be interesting to see what outcomes are particularly sensitive to, what relationships, if we underestimate or overestimate the strength of that relationship, have a significant knock-on impact on the net result. When Alex is ready, because I think she's giving us this general overview of this map at the moment, when she's ready, I have a suggestion of one question to explore in terms of unintended consequences of investment in charging infrastructure.
Great. Thanks, James. Anyone wants to, if you want to have a discussion at some point about this quantification, I mean, we're keen to do it, but the reason we started using network analysis is because the sort of traditional methods of quantification in these models were very sensitive to decisions made by the modeler, more sensitive than they were to the map structure. But here we very clearly want to sort of combine some quantitative aspects that are clearly very important to us. But what we can do already is to sort of do the sensitivity analysis, what's important or not. But it's very interesting actually in this domain. It's a real challenge to sort of avoid the lure of the model. Getting some quantitative results that are actually essentially artifacts, as opposed to getting something from the structure. So it's a very, very interesting problem. So those who are interested in discussing that, let's have a conversation. But just to say, I've got now the factors three links downstream from those initial starting factors. So that's 3 steps away, which kind of starts to take you into different arenas of the map. And if we can explore some of these further and take us even further through the map to see where we have knock-on impacts. So, you know, we've got sort of really interesting things, of course, starting to come up. I think everyone is, well, you know, many people are probably aware that that electric cars have this potential impact on the emissions of PM emissions. So we have a vehicle weight increase, which increases our non-exhaust emissions and then our PM emissions, and we have potential impacts on air quality there. So we do decrease CO2 emissions directly, although of course we have to think about the whole life cycle emissions in order to really understand that. But we've got this increase in non-exhaust emissions, and that's really starting to come out, and all the different sources of emission are starting to come out here. But I think sort of what is starting to get really interesting, and one of the crucial things we really need to understand in terms of rebound effects here, is what this area of the map looks like, what the connections are here. So the EV total distance traveled, connecting to public transport distance traveled, connecting to active transport distance traveled, which starts to connect to other sorts of factors in the map. So things like time outdoors. So, you know, there's interesting trade-offs that might be coming out here. So time outdoors actually potentially increases your outdoor exposure to different sort of sources of air pollution. But, you know, we've got all the knock-on effects that will come from decreased active travel. We've additionally got another fact. I think if we can go into James's suggestion shortly, but I'd just like to take you through here. We're starting to connect up again really to this private car number of trips being increased by the number of electric cars. So if this causal connection is here and we actually get more trips in private cars from moving towards the number of electric cars, we can start to explore further what the consequences of that might actually start to look at. If we go back to the whole map, and if I find private car number of trips is actually a very influential factor, it's a very highly connected factor in the map. So we can start to see, for example, if we're pulling out that one, this is just one step away, but let's look at the downstream. What's caused by private car number of trips? And we actually, you know, we have all these knock-on effects, not just through the sort of direct effects of different types of emissions of different modes, but I mean how people's behavior changes, how the distribution of people, how the demand for travel changes. So this is actually, you know, the sort of stuff we really want to make sure we include here, so we can really try to look at all these knock-on effects. I think I just wanted to kind of point out here, just from following private cars, you know, which seems to be positively, there seems to be increased number of trips in private cars by EVs potentially. We start to get into this whole realm of increasing congestion, and that very strongly emphasized to us in the workshops by our colleagues, our stakeholders involved in bus transport, just what an impact congestion has on the variability of transport time for public transport, and how that very much feeds into whether people want to take buses or not. So for example, you know, we'd have to sort of follow this link through, but essentially this kind of idea that they had was that people's perceptions of control over their journey time, the reliability of journey time for public transport, was one of the really crucial driving factors on whether people would choose to take public transport or not. So you actually have this kind of potential indirect link here through increased congestion, in which buses become less reliable. People want to take buses less. So you've actually got this whole, you know, any kind of congestion would do it, but you know, it's just the increased private car use actually has a really negative impact on the public transport system, potentially, depending on the strength of these links. So you can see it starts to drive down public transport number of links, public transport distance traveled, and that all then essentially starts to, you can't necessarily see it all here, but it starts to increase our emissions ultimately if the kind of modal share of public transport goes down. So, you know, again, very interesting. We'd need to actually give relative weights to these links to kind of follow that through. But this is just the sort of thing that you start to pull out. We've even here got congestion decreasing local economic efficiency. And then that connects into all of our kind of regional, our neighborhood self-sufficiency, impacts on jobs and regeneration. So that starts to connect into this whole local economy as part of the map. So we've got all, you know, all of these connections start to percolate through, which we can.
Thanks, Alex. If you kind of keep the reins on the map,
Sure.
But yeah, but so a couple of segues there really to a question I was going to raise, and I saw that fuel duty features as a factor, and it feeds into public transport operating costs, and as a result their profits and so on. And I think that yeah, the point that Kerry's raised is a really important one, and we should explore, you know, how we can capture some of these then feedbacks into governmental decisions. And if I can use that as a segue, and Alex, your previous mention of indirect effects on public transport, for instance, through increased congestion, I wanted to take a step back and ask the question, through investment and focus on providing EV charging infrastructure, what might suffer as a result of less investment, less focus on behalf of the government?
So essentially, if we go back to charging infrastructure, I think what you're asking is, what are these other, am I zoomed in enough?
I think you are.
What would be the negative,
from,
what would be the other arrows coming out of charging infrastructure, investment in charging infrastructure?
So for instance, there's a black arrow leading into charging infrastructure that I think begins somewhere up above, yeah, from national laws and regulations. And those same national laws and regulations are also influencing, for instance, investment in public transport through subsidies, for instance. So what might suffer as a result of investment in EV charging infrastructure? What are we not investing in? What else should we be investing in, for instance, to stimulate modal shift, as well as a shift from petrol and diesel vehicles to EVs?
So we're essentially sort of thinking, well, it is all downstream. If we've got a sort of zero, it goes immediately to some kind of gigantic influence on the system. I'm not sure if that's real or not. But
it may be one. It may be a question to put to everybody. What, you know, perhaps what else do they think that we should be investing in for modal shift, as well as shift in vehicle technology, that could suffer from a sole focus on EV charging, for instance?
I mean, what we've got here is subsidy for public transport and fuel duty and perceptions of control, but I think it's a more general conversation, right? Sort of what might suffer and what else do we need to be investing in?
Yeah.
I think one of the really interesting aspects of these maps for me is how you use them as storytelling devices in a way. So it's kind of making quite explicit, if you choose this approach, this, I mean, obviously we can't go in and say, you know, there's lots of really good arguments why we should go for public transport as opposed to private car use. But what we can at least do with this kind of approach is say very explicitly, this is what this approach entails. It entails more private vehicles, and this has all of these negative consequences on multiple areas of the map. And look, here's public transport. Alternatively, if we focus on this, these are these are the beneficial things we get. So in a way, we can use this to try to make those cases. You know, so we're here, we put in what is being proposed, but we can also use this to try and explore and almost, yeah, essentially present these kind of narratives, that come from people's thinking about the system. This is what this entails. This was what this would mean. This is what this other thing would mean. And look, you know, so, you know, you can kind of make cases for different scenarios, I think within this kind of sort of framework. And it's interesting because maybe in this domain, I think it sort of seems, I don't know, this is not the domain I normally work in, but it seems particularly value driven, you know, or sort of the worldview driven, to focus on private vehicles as opposed to public transport, which is a sort of really interesting aspect of that. And I don't know if anyone has any thoughts on how to kind of capture that aspect, or is it just something that we hold in the back of our minds when we're doing this work and we're working in that context?
I think just related to that, Alex, the point that this is very much intended as a market-led policy or strategy more broadly, whereas we know that the current policy landscape for public transport, certainly the way it operates in the UK, is that it needs to be subsidised. Essentially, it operates on a series of subsidies, whereas the sort of EV focus, and Jose's point as well, actually, that it's not the most efficient way of moving individuals around at a mass scale, but it's being market led, so it's really speaking to this sort of in industrial narrative, really. Whereas the dichotomy of that, of course, is strengthening investment at a state level in public transport. I think it comes back to these economic factors as well. But it would be really interesting, I think, just to pick up just one comment on the global point, is that the greatest number of vehicles and potential uptake of electric vehicles is, of course, outside the UK. So if we look at China, for example, and volume of vehicles and projections, it's absolutely vast. And if we're thinking about where all those other fossil fuel vehicles are going to end up ultimately, and take it as a global system, then there are potentially really serious negative consequences for low middle income countries, which as Greg said with the example there. So I think you know, global systems level, ultimately EVs could end up with overall negative consequences. So that's something I think we need to reflect upon.
This is definitely something that systems maps and what are called fuzzy cognitive maps in particular are very frequently used to do, and do very effectively, because you can include everything in this map, not just things that you've got empirical evidence for or what you can quantify. So a really useful role for these sorts of maps in general is clarifying mental models. You know, so exactly as you say, Kerry, you can have different groups of people, you know, who are operating in different parts of the system, or maybe with different levels of power in the system, and their mental model, their perception of how the system works, can be really different from others. And that's a really useful tool to actually help generate understanding between groups. Or, you know, this is, you know, what the fishermen think are going on, this is what the policymakers going on. You know, we've often done it in these kind of settings. But I really thought that was a very interesting idea. Where are the knowledge gaps, actually? You know, what maybe the policymakers not know. That's really interesting. I mean, a lot of the work that I've done with this stuff previously, again, like sort of your other point, is very much like the idea of, say, bringing different policy teams, even if they're all on the same floor of the same building, but, you know, different teams working on different aspects of policy, bringing them together such that they actually understand how what they do impacts on each other, and they just get that aha moment, you know. And this is what really works well in a room together. And I think particularly interestingly, because you can see the whole map, it's a giant piece of paper on a table, you're all standing around it, whereas you're not kind of zooming in on a little bit of a screen or something. Suddenly you see we're all part of this same system, and we can actually, what I'm doing is being influenced by these other teams or these other parts of policy over here. And so you get that sort of realization of the system, and you can actually look at where you do interact with others. So those two aspects are both really important, and they're almost sort of the opposite end of the spectrum from each other. But it is really interesting, because I think quite often, yeah, the desire is let's make this into a model that can give us certain answers. But I think the power of these methods is not actually so much in that, as in the kind of understanding how each other thinks and how we're connected.